This video is about finding the limits of functions involving the natural logarithmic functions and the derivatives of the functions involving the natural logarithmic functions. Properties of natural logarithmic function. F of x equal to natural log of x has a base of e. The domain is from 0 to infinity and the range is from minus to infinity. Inverse property is natural log of e to the x is x. E to the natural log of x equals to x. Natural log of 1 is 0. The product property, natural log of u is natural log of u plus natural log of v. Quotient property, natural log of u over v is equal to natural log of u minus natural log of v. Power property, natural log of u to the n is n times natural log of u. Example 1, finding the limit of natural log of x minus 4 as x approaches 4 from the right. So let's start with this one. Limit of natural log of x minus 4, x approaches 4 from the right. X approaches 4 from the right means x is always bigger than 4, so you can substitute a number slightly bigger than 4, like 4.0001, and then it becomes natural log of 0.0001, which is close to minus infinity. Example 2, find the limit x approaches 4 from the left, natural log of 4 minus x. So to find the limit of natural log of 4 minus x as x approaches 4 from the left means you substitute a number slightly smaller than 4. So maybe you can substitute like a 3.99999. So it becomes natural log of 4 minus 3.9991. And we get natural log of 0.001, which is minus infinity. Example 3, find the limit x approaches 3 from the right, natural log of x over square root of 4 minus x. So we can substitute x equal to 3 directly here. So we have a natural log of 3 over square root of 4 minus 3, which is the natural log of 3 over square root of 1, and which is natural log of 3, and this is approximately 1.0986. The derivative of natural logarithmic function. Number 1, the derivative of natural log of x is 1 over x. When u is a function of x, then the derivative of natural log of u with respect to x is 1 over u times the derivative of u with respect to x. So you have to apply a chain rule. So here's an example 4. Find the derivative of f of x natural log of x squared plus 3x plus 4. So we can say u is the inner function of this function, the x squared plus 3x plus 4. So we can replace this with a u. So we have now f of x equal to natural log of u. So now u is a function of x, as you can see. So we can apply this formula, differentiate using the d of dx of natural log of u, which is 1 over u d over dx. So we just write here, so we have 1 over u d over dx of u. Now we replace the u wherever it's needed. So I can have 1 over u changes to x squared plus 3x plus 4. You have a d over dx, and then u change to x squared plus 3x plus 4. Well, this part is done because there's no operator here. Just bring it down as 1 over x squared plus 3x plus 4. But this tells you differentiate all these three terms. So the derivative of x squared is 2x, the derivative of 3x is 3, and the derivative of 4 is 0. So now you can multiply these two. You get 2x plus 3 over x squared plus 3x plus 4. So here is an example 5. Find the derivative of the function y equals to natural log of x times the square root of x squared plus 5. So let's start with this. Y equals to natural log of x times the square root of x squared plus 5. So now we can, since this is the product of two functions, and we can apply the product rule of logarithms, and which is say natural log of u v is equal to natural log of u plus natural log of v. So u is like a x and the v is like a square root of x squared plus 5. So using this property, we can break it down into two logs, natural log of the x and plus natural log of the square root of x squared plus 5. Now it looks like this is like a composite function, and we can rewrite square root as natural log of x squared plus 5 to the 1/2, and you can bring it down natural log of x as well. And now it looks like the log of exponential form, so we can use this power rule, and it's a natural log of u to the n is n times natural log of u. So this means we can bring down 1/2, and we're left with natural log of x squared plus 5. Again, bring down natural log of x. Now let's call x squared plus 5 is equal to u. So this becomes y is equal to natural log of x plus 1/2 natural log of u, where u is x squared plus 5. Now we differentiate with respect to x. So make y is a y prime, write d over dx of log of x, and you can factor out 1/2 and it's the d over dx of natural log of u. And now here that's a simple basic natural log of x, the derivative is 1 over x. But here we can apply this rule, which tells you it's 1 over u, with 1/2 is already there. So 1 over u times d over dx of u. Now what you do, where the u is, you substitute what you call x squared plus 5. So we get this is the derivative of natural log of x, and plus 1/2, and that's 1 over x squared plus 5, and u is changed to x squared plus 5 dx. Now there's an d over dx operator which tells you must differentiate this one. So let's copy down 1 over x, copy down 1 over 1/2, and 1 over x squared plus 5, and here we write the derivative. Well, the derivative of x squared is 2x, and the derivative of 5 is what, 0, so we just ignore that one. So now we have this one. So it looks like 2 is on the denominator, 2 is on the numerator, 2 is in the numerator, 2 is denominator. We can cancel these two. So we have now 1 over x plus x times 1 is x over x squared plus 5. Well, basically we're done, but we can condense into a single fraction. So it looks like we can find the LCD x, so will be x times x squared plus 5. So looks like the first fraction we can multiply top and bottom with x squared plus 5. So it becomes 1 over x times x squared plus 5 over x squared plus 5. Now here we can multiply x over x, this one. So it becomes x over x times x over x squared plus 5. So now we can multiply 1 with x squared plus 5, it becomes x squared plus 5. And here we can put together x times x squared plus 5. And here we multiply x times x squared, and here we put together x times x squared plus 5. And you can see they have same denominators. So these are like fractions, so we can write the denominator x times x squared plus 5 and add the numerators x squared plus 5 plus x squared. Now it looks like we can simplify x squared plus x squared is 2x squared and plus 5 over x times x squared plus 5. Now make sure don't cancel this one, because this is 2x squared plus 5 and this is x times x squared plus 5, and that's the final answer. Example 6. So we're going to find the derivative of y equals to natural log of the square root of x minus 2 over x plus 2. So it's too complicated, so calling it u. So first you apply all the rules or properties of the natural logarithm. So let's start with this. Y is equal to natural log of the square root of x minus 2 over x plus 2. First we rewrite this one in radical form. So it will look like natural log of x minus 2 over x plus 2 to the 1/2. And then we apply this rule, power rule or property, natural log of u to the n is n times natural log of u. So if you apply this one accordingly, I have to bring the power 1/2 down and it write natural log of x minus 2 over x plus 2. So it's still very complicated. So it looks like it's a log of quotient, so we can apply this property. Natural log of u over v is a natural log of u minus natural log of u. Keep the 1/2, put the parentheses, and then write the natural log of the numerator x minus 2, and then minus the natural log of x plus 2. Now we're going to differentiate using d over dx of log of u is equal to 1 over u du over dx. So the first one, we have 1/2, so that'll be 1 over x minus 2 d over dx of x minus 2 minus 1 over x plus 2 d over dx of x plus 2. So we can just copy 1/2, parenthesis 1 over x minus 2, the derivative of x is 1, derivative of 2 is 0. Minus 1 over x plus 2, we copy here, and then derivative of x is 1, derivative of 2 is 0. Now we simplify, so you have 1/2, parenthesis 1 minus 0 is 1, so 1 times 1 is 1 over x minus 2. Similarly, 1 plus 0 is 1, 1 times 1 is 1 over x plus 2. So we have 1/2, parenthesis 1 over x minus 2 minus x plus 2. Now we're going to condense into a single expression. So find the LCD. So it looks like they are different. So the LCD is x minus 2 times x plus 2. So looks like in this fraction x plus 2 is missing. So we write 1 over x minus 2 times x plus 2 over x plus 2. Minus, now here x minus 2 is missing. So we're going to write x minus 2 over x minus 2 times 1 over x plus 2. Now we can copy the 1/2, multiply 1 times x plus 2 over x minus 2 x plus 2. Similarly, x minus 2 times 1 is x minus 2 over x minus 2 times x plus 2. And now we have the like fractions, so we can subtract. So we remove the parentheses here, and we have 1/2 x plus 2 minus x, and minus minus becomes plus 2. X cancel with x, and 2 plus 2 becomes 4, and 4 divided by 2 is 2. So the final answer is 2 over x plus 2 and x minus 2. Example 7, find the derivative of f of x equal to natural log of x plus square root of 4 plus x squared. Now let's write down this, convert this one or rewrite square root into rational exponential form. So we have f of x equal to natural log of x plus 4 plus x squared to the power 1/2. Let's write x plus 4 plus x squared to the 1/2 as u. So this becomes f of x equal to natural log of u. Now we differentiate with respect to x. So it'll be 1 over u times d over dx of u. So now we replace u with whatever we said equals to x plus 4 plus x squared to the 1/2. So this becomes 1 over x plus 4 plus x squared to the 1/2, and d over dx of u, which is again x plus 4 plus x squared to the power 1/2. Now we're going to only differentiate this part. So we copy down 1 over x plus 4 plus x squared to the 1/2. The derivative of x is 1, and write down the derivative d over dx of 4 plus x squared to the 1/2. And this is composite function. We have to apply the chain rule. So, let's copy down this whole thing. 1 over x plus 4 plus x squared to the 1/2. Parenthesis 1 and then 1/2. Bring down the power 1/2, and then subtract 1 from 1/2. And then multiply this with the derivative of the inner function 4 plus x squared. So we simplify this one. We copy down this one as 1 over x plus 4 plus x squared to the 1/2. copy down 1 and copy down 1/2, and then here 1/2 minus 1 will be negative 1/2, so it becomes 4 plus x squared to the power negative 1/2. Now here d over dx tells you we differentiate. The derivative of 4 is 0, the derivative of x squared is 2x. So now we're going to simplify. Looks like 2x plus 0 is just 2x, so we can cancel 2 with this 2. So and this we can write as on the bottom 4 plus x squared to the 1/2, and we can put x on the top. So now we have 1 over x plus 4 plus x squared to the 1/2, parentheses 1 plus x over 4 plus x squared to the 1/2. Now we add 1 into this one and this one. So in order to add this 1 into this one, we have to convert 1 into fraction. The denominator equals to this one. And this we can do multiplying 1 on the top and bottom with this LCD. So now we have 1 over x plus 4 plus x squared to the 1/2, parentheses 1 we change to 4 plus x squared to the 1/2 over 4 plus x squared to the power 1/2, and is copied on x plus x over 4 plus x squared to the 1/2. Now they have same denominators, so we can write this once and we can add these two. So now we have 1 over x plus 4 plus x squared to the 1/2, 4 plus x squared to the 1/2 plus x over 4 plus x squared to the 1/2. We can just rewrite, we can write x first and we write this after that one. So we have this one. Now it looks like this expression is same as this one. So we can cancel these two. You have 1 over 4 plus x squared to the 1/2. Now we can change the radical form. So it becomes 1 over square root of 4 plus x squared. If you rationalize, we get square root of 4 plus x squared over 4 plus x squared.